Myself, Afrin Sultana. My topic is set theory from the chapter Probability and Random Variables. Definition of a set. A set is a well-defined collection of distinct objects called elements or members. The objects in a set are written inside curly brackets. Each object in a set is called an element. Here we see some examples of sets, a set of numbers and a set of fruits. Key points about sets. Sets are usually represented by capital letters, capital A, capital B, capital C, and so on. Elements are represented by small letters, small a, small b, small c, and so on. If an element belongs to a set, we use the symbol belongs. For example, 2 is in a set A. If an element does not belongs, we use does not belongs. Here we see a list of the main types of sets. There are mainly 8 types of sets. First one, empty set. It is also called a null set. Second one, finite set. Third one, infinite set. Fourth one, equal sets. Fifth one, equivalent sets. Sixth one, subset. Seventh one, universal set. And eighth one, disjoint sets. We see about the first one, empty sets. A set with no elements is called empty set or null set. For example, A equals to 5 or A equals to with the curly brackets. It is about empty set. And second one, finite set. A set with a countable number of elements is called finite set. For example, B equals to 2, 4, 6, 8 is a finite set. This is about finite set. And third one, infinite set. A set with endless uncountable elements is called infinite set. For example, natural numbers is a infinite set. And this is about infinite set. Fourth one, equal sets. Two sets with exactly the same elements is called equal set. For example, A equals to A, B, C, B equals to C, A, B. Here set A and set B contains 3 elements and the same elements, that is A, B, C. So it is called as equal sets. This is about equal sets. Fifth one, equivalent sets. Two sets having the same number of elements but not necessarily the same elements. For example, G equals to A, B, C and H equals to 1, 2, 3. Here set G and set H contains 3 elements only but not the same element. So it is called equivalent sets. This is about equivalent sets. Sixth one, subset. If every element of set B is also in set A, that is called a subset. For example, A equals to 1, 2, 3 and B equals to 1, 2. The elements in set B is also present in set A, that is 1, 2. So it is set B is also in set A. So B is subset of A. So it is called as subset. It is about subset. Seventh one, universal set. A set that contains all elements under consideration is universal set. For example, if we discuss natural numbers is a universal set and it is about universal set. Eighth one, disjoint sets. Two sets with no elements in common is called disjoint sets. For example, A equals to 1, 2, 3 and B equals to 4, 5, 6. Here set A and set B contains 3 elements but these sets does not contains common elements. Here that is A contains 1, 2, 3 and B contains 4, 5, 6. Each set is different elements, so it is called disjoint sets. This is about disjoint sets. Here we see some set operations. There are mainly 4 types of set operations. First one, union. Second one, intersection. Third one, difference. Fourth one, complement. Here we see about first one, union. It is denoted by A union B. It combines all elements from both sets. Removing duplicates is. For example, let we take A equals to 1, 2, 3 and B equals to 3, 4, 5. Then A union B equals to 1, 2, 3, 4, 5. Here 3 is common between set A and set B. In the definition of union, we removing duplicates. So we remove 3 and write as one time. So it is A union B equals to 1, 2, 3, 4, 5 and this is about a union. And second one, intersection. it is denoted by A intersection B. It includes only the elements that are common to both sets. For example, if we take A equals to 1, 2, 3 and B equals to 3, 4, 5, then A intersection B equals to 3. That means here set A contains A, 1, 2, 3 and set B contains 3, 4, 5. Here one element is common, that is 3. So it is written as A intersection B equals to 3. By the definition of intersection, it includes only the elements that are common to both sets. So we can return A intersection B equals to 3. This is about intersection. And third one, difference. It is denoted by A minus B or A by B. It includes elements that are in A but not in B. For example, A equals to 1, 2, 3 and B equals to 3, 4, 5. Then A minus B equals to 1, 2. Note and B minus A equals to 4, 5. If we set A contains 1, 2, 3 elements and B contains 3, 4, 5 elements. In A minus B operation, we, we can consider set A elements. That is 1, 2, 3. 3 is present in set B. So we neglect 3 and A minus B written as 1, 2. In B minus A operation, we consider B set elements, that is 3, 4, 5. Here 3 is present in set A, so we neglect 3. B minus A equals to 4, 5 because by the definition it includes that are in A but not in B. So A minus B equals to 1, 2 and B minus A equals to 4, 5. This is about difference operation. And fourth one, complement. It includes everything not in set A relative to a universal set U. For example, let universal set U equals to 1, 2, 3, 4, 5, 6 and A, if we take A equals to 1, 2, 3, then A complement equals to 4, 5, 6 because here we take universal set equals to 1, 2, 3, 4, 5, 6. Here A elements equals to 1, 2, 3. The A elements 1, 2, 3 is present in universal set. Remaining elements are 4, 5, 6. That is our A complement equals to 4, 5, 6 because by the complement it includes everything not in set A relative to a universal set U. So here 4, 5, 6 are relative to your universal set. So that is A complement equals to 4, 5, 6. It is about complement. Here we see some applications of sets. First one, in daily life groups and collections. It representing groups like students in a class, employees in a company, or products in a store. And second one we use in sports, keeping track of players who scored goals, fouls, are played in matches. And it is used in music or movies, creating playlist, set of songs, or categorize films by genre. And third one, in mathematics, algebra, and geometry, sets help define relations, functions, and coordinate geometry. And fourth applications are probability and statistics. Events are treated as sets of outcomes. Venn diagrams used to visualize intersections, unions, and complements of sets. And it is also used in computer science databases, searching recorders using set operations. For example, finding students enrolled in both science and maths intersection. And it is also used in programming. Many languages have built-in set data structures to remove duplicates or check memberships. That means in programming we use the structures and we require to remove duplicates, so it is used in programming skills. And next one is networking. IP addresses, routing, and user groups rely on set theory concepts. And it is also used in logic and research surveys or polls. Analyzing data, for example, people who like tea or coffee or both. And classification, it is used to grouping species in biology or classifying books in a library, and it is used in decision making. That means comparing options using sets of advantages and disadvantages. It is all about the applications of sets. Thank you for this opportunity.